Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of identifying proportional and non-proportional functions. This is standard 8.5H in the great state of Texas, and we are using item number 5 off the 2021 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got 4 tables. We are simply looking for one that shows a non-proportional relationship, which means we need to differentiate between the two. So proportional relationships are those that we can view using what we see on our mathematics chart as being labeled direct variation. So that is going to be y equals kx. Very simple. You got your independent variable, you multiply it by some type of number there, k, and you get your dependent variable. And that means that we can actually also turn these into proportions if we want to solve these problems. That's why they're called proportional relationships. You can just solve it using a basic proportion rather than the equation. But when you get into your non-proportional, that's when things get a little bit strange. Now we're used to the non-proportional relationships. We just call those the slope-intercept form. And so the reason there's a slope-intercept form because it starts the same. You got y equals mx, so this m and this k, right, can both be seen as a slope if we were to graph it. But we got a plus b, and that always changes it because it's always a little bit something extra. And so the big difference is if x equals 0, well in this case y would equal 0. Because it's just going to be multiplied by that k, and anything times 0 is 0, so that means it goes to the origin. But if x equals 0, here y equals b, and that's where you get that y-intercept. So it does not go through the origin if you were to graph it. So that's the difference between proportional and non-proportional. So that means 3 of our answers are going to look like this, y equals kx. And the one we're looking for, our correct answer is the one that does not look like that. It's got a little bit more of a y equals mx plus b. So how do we figure this out? Oh, we have our tables. Well, let's find the easiest pair on each of these and see if we can just find a basic multiplication, right? So y equals mx plus b. So I'm going to start with this. This looks like a pretty simple pair here. So y, that's -4. We're going to look for, let's just start with this y equals kx. See if that's the case, because if so, we can just discard it. Something times x. So I'm going to put that little blank right there. Times our x is 1. So 1 times something makes -4. Will have to be -4. So if k equals -4, does that work over here? Does -12 equal -4 times 3? Yeah. This -28 equals -4 times 7. Yeah, okay, so it works all the way down. So then that's not our answer. That's your proportional, it's just y equals kx. Let's find something simple that looks like that's going to be the simplest right there. So -11 equals something times 2. What can I double? It'd have to be -5.5. So k would have to be -5.5. Let's look at this down here. -55 equals -5.5 times 10. Yep, that works. And then it works for these two as well. If you want to check those out, you can. So it's not B, all right? Oh, let's look at C. C is super easy. It's going to be 7.5 equals something times 1. Well, that's going to be 7.5. So then does 30 equals 7.5 times 4? Yep, all right, so that's not it. So look at this right here. -1 equals something times -1. Well, that'd have to be 1. But does 11 equal 1 times -5? Nope. Does -7 equal 1 times 1? No. So there's a plus b here we're missing. So our answer is D.